Tell me you're an engineer without telling me you're an engineer. Crusher this year was hard. And yeah, 906 events are supposed to be hard. But this year, there was a really big jump in difficulty. There's been a lot of chatter calling it the Crusher Gessic, and I wanted to look at data, make some charts to see if I could statistically show a difference between previous years and this year's ride out of Copper Harbor. And just looking at the course file ratings, there is a big difference from last year to this year. Same mileage, more than double the elevation, and we got an extra 5 hours, which made it doable. So if we did not have those extra 5 hours, there would have been only 12 people that finished this year. Yeah, that would have been rough. So that's the start of it, is by ratings, it is harder. But how much harder? I made some tables comparing last year's course, both my friend's total course file as well as my own, and comparing that to some of my training rides, other long endurance rides. And you can see that this year's Crusher kind of lies right in the middle of everything. So it's definitely easier than Marji, but it's definitely harder than last year's. But I wanted to put a number to the difficulty. So what I did was I took all of the finisher data from Superior Timing as well as Bike Reg. So I knew how many people had signed up for the race, because I wanted to test to the whole population, not just the people that finished and not just the people that rode. Visually, all of that can be shown as a histogram, and there is an ideal normal distribution. So you can see the blue boxes are the ideal distribution, so normal distribution, but if you get a random sample, it doesn't always match. It gets fairly close, but it's never going to be exact. But the longer you let this go, the more samples you get, the closer it's going to be to ideal normal distribution. But there's always going to be some discrepancy. So this whole analysis, it has a couple of caveats to it. There are course changes, so one year to the next isn't really comparable, as well as non-normal data distribution. Like, you can't really control for what riders are lining up. You can't really control for weather conditions. It's all probability. It's the black magic of maths. As well as there's an argument to be made that there are very few repeat riders, so it's a completely different population every time. The people that just get it done and move on. So all you have left are the people that have to work their butt off just to do the thing at all. So right off the bat, this histogram does not look normal. You can see that there are kind of two lumps to the graph. And part of this may just be because we don't have a large sample of data. There were only 49 people that finished the course. That's not a very large set. Another thing to note, I grouped people that finished within 20 seconds of each other as like riding groups, riding partners. And one, I think that's really interesting because of the finishers, there were either 50 to 60% of the people that crossed the finish line were riding as a group, which I think is an interesting reflection of community, helping each other, looking out for one another. I think that's pretty cool. But also, it messes with my data, specifically looking at the 20 to 21 hour finish range, there were 3 riders that finished together of those 4. It's quite possible that if they had ridden separately, one of them might have been able to go faster, not waiting for the other riders, or one of them might have been slower without the motivation to pedal from their riding buddies. So that could have smoothed out the distribution a little bit better. With a 38% green dot rate. So these are only the people that finished under the cutoff. So that's 40 people out of the entire population of 106 people who registered for this event. So that 38%, assuming a normal distribution, will correspond to a z-value, which indicates the probability of a value being higher than a given statistic value. So in this case, we're looking for 38% on the left side of the curve, so the top 38 percentile, and that corresponds to a negative 0.3 z-value, which means that to find the statistical average of the population, we'd add 0.3 of a standard deviation to the cutoff to get our theoretical average finishing time. So the standard deviation was calculated based on the riders who met the cutoff time, and that standard deviation was about 2.5. So if you add 0.3 of 2.5 to 29 hours, you get 29.74 hours is the statistical population average finishing time for this course, which is 45 minutes beyond the time allotted. I also wanted to look at the flip side, the people who didn't even show up, the DNS category. There is a complementary z-value, so showing the right hand of the curve, and of the 106 registrants, 10 of them didn't show up, so 9.4%, and the z-value that corresponds to that is 1.32. So that's standard deviations, 1.32 standard deviations above the population average, which visually it shows up on the curve like that. So if you take your probability of finishing, riding, and missing the cutoff, or not even showing up, this is kind of what it looks like. So if you are an average rider, you are statistically likely to show up but miss the cutoff, even if you can finish the course. And once you get farther above that average, I mean, those are the people that just kind of realize that maybe I signed up for something I shouldn't be at. So that's the analysis for 2025, but now we need something to compare it to. So I'm going to do the same analysis for 2024. And right off the bat, you can see that this curve is a lot smoother. Like visually, it looks like a normal distribution. And you had a higher percentage of finishers, more people registered, but less people started, which I think is really interesting. There were 30 people that didn't even start last year versus 10 this year. So running that same analysis of finding your standard deviation, finding your z-value that corresponds to the finisher rate. So for 2024, the statistical average time would be 23.85 hours based on the total population, which is within the 24 hours that we were given. You had a 9-minute margin of error. But statistically, your average rider could have finished Crusher last year. Going back again to Crusher 2023, that one had an average finishing time of 22.45 hours, which is actually very similar to 2022, which is 22.41. So again, 2022, 2023, 2024 all had a statistical average within the cutoff time. So your average rider would statistically be able to finish. 2025 is different. The statistical average is beyond the cutoff time, so your average rider is statistically likely to get crushed. You can see that these are getting harder year over year. But Crusher isn't the only race that 906 puts on. So I wanted to get a larger population, so I did this for Marji 100 2025. No, 2024, last year's, not this year's, last year's Marji. And you can see it's not a normal distribution again. You've got almost a linear ramp of people finishing between 10 and 18 hours, and then the whole field just flattens out. If you split this into half-hour increments, it almost looks, again, like there are two bell curves on top of each other again, just like 2024's Crusher. And then if you perform the analysis for the average and the statistical likelihood of the average person finishing with a 25-hour cutoff, the statistical average of the population for Marji Gesick 100 2024 is 25 and a half hours. So again, statistically likely that the average rider will not finish. This is kind of looking like this year's Crusher. So you have the people that are drawn to this event and are good at it, and then I theorize that you have the people that are just trying to get it done. This Crusher, this distribution, looks a lot closer to Marji distribution than it does to the previous Crusher years. Like, looking at the data and statistics, this is now a mountain bike event.
Which is why you actually enjoyed this year's Crusher.
Yeah. I mean, I like this stuff. I even like the analysis of this stuff.
No.
28.2 to 23 were very similar. 23 to 24 ramped it up by more than an hour. And then 24 to this year went from almost 24 to almost 30 hours. So we were given an extra 5, but the field statistically moved up by about 6.
Wow.
So this year, if he'd set the cutoff to 30 hours, you would have had a grace period of about 15 minutes. That would not have made a difference in the outcome, but statistically, I think it would have been a more fair cutoff. How many times can I say statistically? I mean, you may be able to argue that last year's Crusher is pretty darn close to Marji. That's almost sitting on top of each other. And I think last year was a very fair Crusher. I don't want to complain too much. I'm very glad that we got an extra 5 hours. But with respect to the statistical average performance of people out there, it's not as inclusive a cutoff as previous years have been.
I think that's a fair analysis.
Just looking at these two figures, the people that came to this year's Crusher, I think they generally had a better idea of what they were getting into, and they were more mentally prepared to face it, because it had the lowest DNS count and rate of any of the races that I analyzed. So like the people that went up to the Keweenaw, they were all in. It's a very specific group of people that showed up for this one.